right, I'm just gonna kind of do a speed run through this one. We're given a displacement function. So we're trying to find the position of this object as a function of time. To find just to go starting at A, to find the velocity, you just take the derivative of this function, and you should get either something along the lines of t minus 6 times 3t minus 6 is equal to v of t, or you can expand it out into this form. The velocity at 2, at time equals 2, all you do is just basically plug in 2 into the velocity equation, and you'll get 0. The particle is at rest when v is equal to 0 or when a is equal to 0. And that is at t is equal to 6 and 2 seconds. And you can see that by setting v of t to 0. And you can just, or you could just plug in 6 into here or 2 into here. And either of those will give you 0. When velocity is positive, it's moving to the right. When velocity is negative, it's moving to the left, because velocity has a magnitude in the direction of s. So if it's a positive velocity, it has to be moving to the right. The total distance is the absolute value of the displacement function. So you basically, if you were to graph this, v of t would look like this, but the absolute value version of the graph would just look like this, where you would basically flip the bottom part over the x-axis so everything is positive, yielding a total distance. When you integrate the velocity function with respect to time for these three integrals, this negative value becomes positive, so you get a total distance of 224 versus the 160 meters that you would get if you just plugged in 10 seconds into time. All right, for part G, we have the acceleration is just the derivative of velocity over time. Turns out to be 6t minus 24. The acceleration at t equals 1 is 6 minus 24, which is negative 18 meters per second squared. And the time intervals where it's speeding up when the acceleration is getting greater. So like from here to here, it's speeding up. From here to here, it's speeding up. And from here to here, it's speeding up. Okay, and I labeled out those intervals. And we should also have one more, and I should just say speeding up here. Speeding up. And that's going to be from 0 to t to 2. Okay. And then it's slowing down on these intervals where the slope is getting closer and closer to 0. And it's starting to change into a negative acceleration. All right, well, that should answer your questions.